In this video, we will discuss SN2 reactions. SN2 stands for second order, that's the 2, nucleophilic substitution, that's the SN. Before we cover SN2 reactions in detail, however, I'd like to discuss substitution and elimination reactions in general. Anytime an organic compound has a highly electronegative atom within it, or an electron withdrawing group like a double bond or a triple bond, it can undergo an elimination or substitution reaction. In a substitution reaction, the functional group is replaced by another atom or group. In an elimination reaction, the functional group is eliminated along with a hydrogen from an adjacent carbon. The atom or group that is replaced or removed is called the leaving group. An SN2 reaction is a second-order nucleophilic substitution reaction. Second order means that the reaction depends on the concentration of both reactants, and the reaction rate, in fact, depends on the concentration of both reactants, because both reactants are involved in the transition state of the reaction. Let's look at the basic mechanism for an SN2 reaction, where X is fluorine, chlorine, or bromine. The nucleophile attacks an electrophilic carbon, who passes its shared electrons to the leaving group. In general, for these reactions, weak bases make better leaving groups. SN2 reactions happen in one quick step, with everyone involved. This has implications for the circumstances in which an SN2 is likely to occur. Let's examine the SN2 reaction between a hydroxyl ion and bromomethane. Because of the electromagnetic repulsion hydroxyl groups have with bromines, the hydroxyl group tends to approach from the side of the carbon opposite the bromine. The bond between carbon and hydrogen isn't polar, so the hydrogens bound to carbon are not electrophiles, while the carbon, which is bound to the more polar halogen, is. The fewer substituents there are on the carbon bound to the leaving group, the more likely this alkyl halide is to undergo an SN2 reaction. In fact, a methyl carbon is more likely to react this way than a primary carbon, than a secondary carbon is, and finally, a tertiary carbon is least likely to undergo an SN2 reaction. Finally, strong bases make the best nucleophiles in these reactions. So this hydroxyl ion that we used would be a really good nucleophile. As the nucleophile approaches the carbon, the groups attached to it get shoved away like an inverted umbrella during the backside attack.